Well, good morning or good afternoon, depending on where you're dialing in from. Thank you for joining us today for this on-the-record conversation about carbon management projects and industrial emissions. This event is sponsored by the Carbon Capture Coalition. My name is Ben Finzel. I'm president of Renew PR in Washington, D.C., and I'll be serving as the moderator for today's conversation. And what a timely conversation it is. 1 week ago, I think it was actually 1 week ago today, the Biden-Harris administration announced a new industrial decarbonization policy addressing several of the topics we're going to discuss today. And the need to address hard to decarbonize sectors like industry continues to grow. Carbon management technologies can address many of these challenges, such as the emissions from cement and steel manufacturing. And we're going to talk about some of those today. I'm thrilled that we have representatives from two leading industrial giants with us today, Leo Barrera from Lafarge-Holcim and Colin Grays from ADM. We'll also be joined by Lee Beck of the Clean Air Task Force, Jason Albritton of the Nature Conservancy, and Zoe Lippman of the AFL-CIO Industrial Union Council, along with our very own Jesse Stolark from the Carbon Capture Coalition staff. I'll introduce each of them in a few minutes, but first a note that we will have two Q&A opportunities today. The first one will follow Lee Beck's overview of the Clean Air Task Force projects database, and the second will follow the remarks from our expert guests. You're welcome to start putting your questions in the chat or Q&A box now, or you can wait until we begin the first Q&A in a few minutes and ask them live if you prefer. So let's get started. I'm delighted to introduce Jesse Stolark, the Public Policy and Member Relations Manager for the Carbon Capture Coalition. Jesse, over to you.
Thank you, Ben, and thanks everyone for joining us here today. So as Ben mentioned, I am Jesse Stolark, the Public Policy and Member Relations Manager for the Carbon Capture Coalition. And I just have a few slides to share with you, sort of a framing, so I will go ahead and do that. So we're here today to discuss the tremendous progress we've seen on carbon management project announcements in reaction to the 45Q tax credit, as well as discuss further the engagement of the industrial sector in deploying carbon management technologies. Before we dive into today's discussion, I just wanted to provide a little background on who we are as a coalition in case you are not already aware. Today's speakers are broadly representative of the unique partnership formed by the more than 90 industry, labor, conservation, environmental, and energy policy organizations who make up the Carbon Capture Coalition. Our coalition is a nonpartisan collaboration to build federal policy support to enable economy-wide commercial scale deployment of carbon management technologies, which includes carbon capture, removal, transport, utilization, and storage from industrial facilities, power plants, and ambient air. Today, we'll hear more about deployment of these technologies in the industrial manufacturing sectors and why doing so is absolutely critical to meeting mid-century climate goals, while also preserving and expanding the high-wage job space provided by these sectors that in many cases form the backbone of regional economies throughout the United States. So just very briefly, the industrial sector is responsible for 23% of the domestic greenhouse gas emissions and faces unique decarbonization challenges. For a few reasons. One is it relies on high temperature process heat that is readily provided by fossil fuels. Additionally, over half of the emissions in the sector are inherent to physical or chemical processes of converting raw materials to manufactured goods. Carbon management technologies provide a unique solution to reduce emissions in the sector in a timeframe consistent with mid-century and net zero targets. Before we turn to our excellent panel, I'll just give a high-level framing of the landscape of enabling policies for the sector. Last year saw historic and unprecedented federal investments in carbon management technologies through the Bipartisan Infrastructure Investments and Jobs Act. The coalition has been working towards establishment of many of the programs contained in the law since the 45Q tax credit was revamped in 2018, recognizing that a complementary federal portfolio focused on research, development, and deployment of these technologies is needed to reach economy-wide deployment by mid-century. The $12.1 billion for carbon management provisions in the infrastructure law are a really big deal, and we actually talked about that at our last briefing, but includes funding for large-scale pilot projects and demonstrations, as well as containing the full authorized funding for the SCALE Act, a critical piece in ensuring that we have the appropriate transport and storage infrastructure for large-scale project development. Now the coalition is focused on enactment of the enhancements to 45Q, which are necessary to close the cost gaps on deployment of carbon capture technologies across key sectors, including steel, cement, and refining, electric power, and direct air capture. These provisions listed here are what's included in the Build Back Better Act tax package and include important enhancements needed to deploy projects at climate scale, including a 6-year extension and direct pay option for the tax credit, as well as increased credit levels for industry, power, and direct air capture, and reduction of the annual CO2 capture threshold levels. So with that quick introduction and of the state of play, I'm going to hand things back over to my colleague, Ben.
Thank you, Jesse. I'm happy to introduce our friend Lee Beck now. Lee is the International Carbon Capture Director for the Clean Air Task Force, and she's going to provide an overview of their project database and then take a couple questions. Lee, thank you so much for joining us today, and please share your screen now.
Yeah, thank you so much, Ben. Thank you so much, everyone, for joining us today. It's great to see such a large crowd. Thank you so much to Ben and the Carbon Capture Coalition for having us here today. My name is Lee Beck. I run the carbon management program at the Clean Air Task Force. We're an environmental and climate organization who's been working on this for over a decade. We have teams working on carbon management technologies, not just in the US, but also in Europe and the Middle East. And from our perspective, we're really looking at carbon management technologies as part of a system of decarbonization options and decarbonization portfolios, so from an energy systems perspective. And for us, it's really a key option that we need to be commercialized as soon as possible to have multiple options or technologies available to decarbonize and to enable communities and regions to really choose technology pathways to net zero that are suitable to their individual social, political, economic, and resource circumstances. So from our perspective, carbon management technologies are really, really important to future-proof and current decarbonize current industries such as cement and steel. Cement, in fact, in the cement sector, we do not have any other alternatives for decarbonizing at this point in time, but also to provide clean, firm power. Of course, we need as many renewables as possible, but we really need to be thinking about clean, firm power 24/7. And then, of course, also to deliver permanent carbon removal via direct air capture and CO2 storage. And before I go into the database, I just wanted to highlight a few things because this is really about industrial emissions. And I think one key aspect that was overlooked by the International Energy Agency's net zero report that was released last May is that not only do we need some 7.6 gigatons of capturing capacity to capture and store CO2 by 2050. But this is even in a world where we're not commissioning additional fossil fuel development and dramatically reducing our reliance on fossil fuels. That is because carbon management technologies are so important for achieving net zero emissions, and especially in the industrial sector. This is about asset transformation, really making sure that we're, again, future-proofing existing assets. So going over to our Clean Air Task Force database, and you should be able to see it right now. The US government has done more than any other government in the world to commercialize carbon management technologies. And this is really reflected in the commercial activities and interest that you're seeing on the screen. There's more than 80 projects, close to 90 projects that have been announced across the United States ever since the reform of the 45Q tax credit in 2018. So there's been also an unprecedented growth of carbon management projects. In 2021, we added more than 51 projects. So, and 70% of the projects that have been announced are actually in the industrial sector. So if you use the database, you can see cement, hydrogen, industrial hubs, waste to energy. And then if you're actually, what's really cool is you can download the data behind this map on our website for free. So we want to make sure that everyone is aware of this really, really cool tool. And what you can see here is that 70% of the projects announced in the United States are also planning or considering to store CO2 in geologic stores, saline geologic formation. So what we're really seeing is the result of further policy action. So the infrastructure bill, which had $12.1 billion in funding for CO2 transport and storage, including direct air capture hubs, is really that, as you can see on this map, right now, most of the projects are being announced where there's existing storage, so that's the gray area. But more and more with this additional funding for CO2 transport and storage, we're actually seeing other regions look at carbon management technologies, even though they're not closely located to CO2 storage, but CO2 transport and storage funding makes it possible for all regions in the United States to access carbon management technologies as a decarbonization solution, even though they might not be located close to storage. However, I think one key aspect that is really, really important to understand here is that as part of a bigger carbon management policy framework, so there has been the Infrastructure Act, of course, we still need, as a climate policy framework, the Build Back Better Act to be passed, which has really, really important improvements of the 45Q tax credits, which will make it really, really impactful for the industrial sector decarbonization. So this includes direct pay, an extension of the commence construction deadline, which is currently at the end of 2025 and further out. And then $85 for industrial and power sector, $85 a ton of CO2 stored for industrial sector and power sector applications, as well as $180 for direct air capture and storage incentives. And this is really an important piece of the puzzles because it will allow more emitters to tap the infrastructure, CO2 transfer and storage infrastructure investments that have been enabled by the Infrastructure and Jobs Act. And one thing that I will leave you with is a Rhodium Group study that really investigated the opportunity for the $85 45Q tax credit in the industrial sector. And it really says that it has a transformative impact, particularly for cement, steel, and hydrogen production. And by 2035 could unlock an additional 100 million tons of industrial decarbonization annually through really making the investment into decarbonization through carbon capture and storage in cement, steel, hydrogen economic for the first time, and really providing that incentive. So I think I will stop here. I encourage you all to use this really cool tool. As you can see, you can click on the different projects, see where they will be storing the CO2, what the latest information is. And we're actually updating this every quarter. So expect around April or May another update on the latest, and as well as analysis on what has been announced in the past couple of months, just because the carbon management project is just growing so fast.
Thanks again, Lee. We have a few minutes for questions about the database. We broke out this Q&A because we thought there might be some specific questions about the database, about the list, about the map, et cetera. You can look at this yourself at catf.us and just follow. I think it's probably highlighted somewhere on the site. Is that right, Lee, or did I have to search for it?
Yeah. It is. It should be more prominent. And I also just wanted to show, if you're looking to download the Excel spreadsheet, the Excel spreadsheets are here. So this kind of not very visible 3 dots, this is where you can download the spreadsheet or switch to the Europe map. So we have the same for Europe and the Middle East as well.
So do we have questions?
I see multiple are in here.
Do we have questions for Lee?
I have one.
You can go right ahead. Just say your name and where you're from, if you don't mind.
Sure, I'm Craig Bettenhausen from Chemical and Engineering News. Hi, Lee. So I was wondering about the 7.6 gigatons number that you quoted. I wanted to clarify, does that number assume that, starting in 2022, the oil and gas exploration budgets are zero? Is that really what that number is? Just wanted to clarify.
7, I mean, we can look exactly. I am happy to send you the report and also clarify with the International Energy Agency. What it says is that we're not investing beyond what's already commissioned today and dramatically reducing fossil fuels. I'm happy to post the link to the study in the chat if that would be helpful for you.
Sure, that'd be great, thank you.
Sure.
Other questions? You can just chime right in. You can use the raise hand feature. You can put it in the chat and I'll read it out loud. I'm scanning through here. Any other questions for Lee? We have another Q&A opportunity, so if you don't now, it's fine.
Yeah, I have a question for Lee. It's Nick Kuznets from Inside Climate News.
Hi, Nick.
Can you tell me, do you have estimate on what portion of industrial emissions, whether US, like you can just start with, United States, could be addressed with carbon capture?
Yeah, I think, Jesse, didn't you have that on your slide just now? I think 23% of emissions are, US emissions are in the industrial sector. I off the top of my head, I don't know exactly how many would be process emissions, but I think, Jesse, you had something on your slide, is that right?
Yes.
But are you saying then that all of the process emissions could be dealt with through carbon capture?
So industrial decarbonization is very complex and comes down to each of the plants, if that makes sense. So industrial decarbonization is, or carbon management technologies in general, it's not a one size fits all approach. So it really comes down to the plant level, to the application level. If you're producing hydrogen, if you're decarbonizing a refinery, if you're decarbonizing cement or steel plant, that really depends. I'm happy to provide further resources for you to really dig deeper into the plant level decarbonization options of all of and how everything works together. Sorry,
Yeah,
Jesse, jump in.
No, I was just going to echo what you were saying, Lee. It's really, unfortunately, not that simple. These are individual facilities and they're very complex. And so, yes, over half of the emissions are process emissions, but in terms of looking at individual existing facilities, it's almost going to be a purpose-built solution.
So I guess I'm wondering, is there any estimate out there that I assume would partly rely on cost, just about like, because if to say 23% is industrial, just like how, I mean, what percentage of that could realistically be dealt with through carbon capture?
Yeah, I mean, we're happy to get back to you with kind of the information that we have. I just cited a Rhodium Group analysis that looked at the different sources where carbon capture technologies would be feasible. So if that would be okay for you, I think we can provide additional resources to you after this briefing.
That would be great. Yeah, thanks.
Thanks for the question, Nick. Any other before we move on? We're going to come back and have lots more Q&A. Any quick questions on the database?
Yeah, hi, this is Kay Kaufman from RTO Insider.
Hi, Kay.
Hi, just wanted to know all these different little circles. Are these projects in development, online? Or is that in the spreadsheet? What are we seeing here?
Yeah, thanks, Kay. It's so good to welcome you here. Yeah, these are all the projects that have been announced since 2018, since the reform of the 45Q tax credit. In 2018, the 45Q tax credit was raised to $50 a ton for CO2 stored. And so ever since, because this is the most significant technology specific incentive for the commercialization of carbon capture technologies, there has been this unprecedented activity. So we are, as I said, updating this under development. I think in the US currently there's 12 facilities operating, capturing and storing roughly 23 million tons of CO2 annually. This would be a different database that is not owned by Clean Air Task Force, but I think maintained by the Global CCS Institute. Is that correct, Jesse and Ben? Yes.
Thank you very much for that. And Kay, we'll come back and we can address that again. So that's the last question for now. We want to make sure we move on. We're going to hear about the role of carbon management technologies in addressing industrial emissions from two leading representatives. Leo Barrera is Director of Government and Public Affairs for Lafarge Holcim. He will speak first, followed by Colin Graves, Vice President Innovation for ADM. And one note before we begin, to be clear, we talk about carbon management most frequently, and by carbon management, we mean carbon capture, carbon removal, carbon transport and storage, and carbon utilization. It's a comprehensive approach to managing carbon and addressing climate, job creation, and economic development. But let's get started with Leo. Leo, over to you.
Thanks, Ben, and thank you, Lee and Jesse, for a wonderful overview. It's a pleasure to be here with you this afternoon. For those of you that don't know Lafarge Holcim, we are a global building materials manufacturer. We are over 80 countries. We have the distinction of being the largest cement producer in the United States with over 13 cement plants and providing building material solutions to all 50 states. If you know anything about cement manufacturing, you know it's a very carbon intensive process, but you may not know why. We were starting to talk a little bit about it, and it refers to these process emissions. Depending on the plant, each plant, as covered earlier, is different, but you can say about 50% of the emissions are process emissions, which means you could electrify everything, use all alternative fuels, and you would still be generating 50% of your emissions. And that is because it's the chemical transformation of taking raw material, in this case limestone, heating it up, and converting it to clinker and ultimately cement. That conversion generates carbon in the process. So the best way I kind of illustrate this for folks is, it's like taking an Alka-Seltzer and putting it in water. All the bubbles that are generated, all that fizz are process emissions, and we have to figure out how to capture them. So Lafarge-Holcim, a number of years ago, became the first building materials manufacturer to take a net zero pledge. We worked with the science-based target initiatives to develop our net zero roadmap, to set intermittent targets, publish them, and really to work with our partners to hold us accountable. And I am pleased to report today that we are well on our way to reaching our net zero targets. And a crucial component of that is carbon capture. As I pointed out, we are doing changes to our manufacturing sites to change the way we manufacture cements, kind of tweaking the recipe. We're integrating renewables, we're increasing our use of alternative fuels, but yet we are still generating a significant amount of process emissions. And the key for us to reach net zero is really getting carbon capture, utilization, storage projects online. As a global company, we have over 20 projects around the world where we are currently studying this, partnering, and trying to develop, de-risk, and scale the technology. In the United States, we have 2. We are fortunate enough to have support from the Department of Energy to be conducting front-end engineering design studies, one at our Portland cement plant in Florence, Colorado, and another at the St. Genevieve cement plant in Missouri. These 2 projects are a partnership with technology providers, the Department of Energy.
Can you hear me?
And all right. And I'm happy to be here to talk to you a little bit more about those projects. And I hope we can get into it at the Q&A part. I think we are at a crucial point. I think the changes in 45Q that are in Build Back Better, the changes that are being developed in IIJA are a critical point. I work for Lafarge-Holcim in the United States, so I have a nice little healthy competition with my colleagues in Europe, and I get to see what other countries are doing to invest in carbon management, and I'm glad to see the U.S. is stepping up to the plate, because the future of American manufacturing, the way, cement is a global commodity. We are going to be needing cement and concrete, and we can import it or we can manufacture it here. And I think the American worker can manufacture it better and cleaner. And that is why we are excited to be here with the Clean Air Task Force, the Carbon Capture Coalition. And with that, I will turn it back to you, Ben, for some questions, or to turn it over to Colin.
Thanks so much, Leo. And I'm really happy that you're able to be here. It's really important to talk about these industrial emissions and the realities of the marketplace and the realities of the projects and what's happening. And I'm thrilled that we have ADM with us as well. And Colin, I mean, you guys have real world experience you can talk about here from several different perspectives, from storage to a couple other things. So I'll turn it over to you to share a little bit of insight.
Perfect. Well, I appreciate this. And Ben, as Ben mentioned, I'm Colin Graves, and I'm the Vice President of Innovation for ADM. First of all, I want to say thank you for allowing me to take the time to talk about ADM, our work on decarbonization, and the role CCS has played as we continue to further reduce our carbon footprint. ADM's purpose is to unlock the power of nature and enrich the quality of life. We do that in many ways. We're a premier global human and animal nutrition company. We're blazing new trails in supplements and ingredients to support health and well-being. We're a cutting-edge innovator leading the way to a new future of plant-based solutions to replace petroleum-based products. And we're the leader in sustainability, scaling across entire value chains to help safeguard our planet. ADM is committed to taking a leadership role in decarbonization of the ag and food value chains. We are using scale, supplier relationships, partnerships, and innovation to deliver a collective impact. 10 years ago, we started permanently sequestering carbon 1.5 miles underground in Decatur, Illinois, where we hold the only 2 Class 6 wells in the United States. To date, we've sequestered over 3.5 million tons of CO2, which is the equivalent of removing about 750,000 cars from the road for a full year. Earlier this year, we were proud to achieve net carbon neutral status for our U.S. flour milling operations. This is a wonderful accomplishment, with it being an industry first of its kind and its scale. We achieved this through implementing energy efficiencies at the plants, sourcing green energy products, and through our CCS capabilities. With the success of that project, we've announced plans to utilize CCS and other advanced technologies to decarbonize more of our large manufacturing processes and lower the carbon intensity of many of the products we make. For example, in April of last year, we announced a partnership with 8 Rivers that proposes to construct a new zero-emission power plant in Decatur, Illinois, which would utilize our existing CCS site. The plant has the potential to displace over 1 million tons of CO2 per year while emitting no air pollutants. We are also exploring ways to convert fuel ethanol into sustainable aviation fuel and other renewable hydrocarbons. In order to further decarbonize our facilities and reach our ambitious sustainability goals, we announced last month a project under which we plan to partner with Wolf Carbon Solutions, who will build, own, and operate a CO2 transportation system. That system will capture CO2 from our Cedar Rapids and Clinton, Iowa plants and pipe the CO2 to our existing site in Decatur, where it will be permanently sequestered. Each of these projects have the potential for significant carbon reductions, but are built on the success and learnings of our initial CCS project over 10 years ago. This is an excellent example of the potential of this technology and the cascading effects it can have for many different industries and products. The key to the industry's development, however, is the 45Q tax credit. It's been instrumental in providing a stable long-term incentive for sequestration, and it's important that it be further extended and expanded to allow for deployment at scale across industries. At ADM, we're also working with farmers to source low carbon intensity crops for us to process. This, coupled with the removal of CO2 from our production processes through sequestration, will allow us to produce low carbon intensity products. So with that, Ben, I'll turn it over to you.
Colin, thanks so much. So helpful to have those real world examples. So I want to turn it now to 2 other experts who are going to give us specific insight into the job creation and economic development and climate impacts of carbon management projects focused on industrial emissions. First, we're going to hear from Jason Albritton. Jason is the North American Director of Climate and Energy Policy for the Nature Conservancy. And then we're going to hear from Zoe Lipman, the Deputy Director of the AFL-CIO Industrial Union Council. And after the remarks of these 2 panelists, Lee's going to come back. Actually, she hasn't left, she's right there. And I'm going to lead a Q&A with all of our panelists, including Jesse as well. You can start asking questions now in the chat if you want to type them in there, or you can just wait until we go to the Q&A right after Zoe, and you can ask them live. But first, over to Jason.
Thanks, Ben. So as Ben said, I lead climate energy policy for TNC in the US and spend a lot of time focused on addressing the challenge of climate change. TNC is a global conservation organization. We work in all 50 US states and over 70 countries around the world. And we really view climate change as one of the greatest challenges we face today. And it's a top priority for our organization to try to address through a variety of efforts, including what I'll be talking about today. From our perspective, the science is very clear. We must reach net zero emissions by 2050. It's where we need to be as a country in the US and as a planet if we're going to stave off the worst impacts of climate change. As we think about addressing climate change and dealing with the sources of emissions, much attention to date, particularly in the US, has been really focused on reducing emissions in the electric utility and transportation sectors of the economy. And these are our two largest sources of emissions in the US, and it's rightful that it's received so much attention. But dealing with those sectors alone will not solve the problem. And that's why we really must focus attention on the industrial sector, which we're talking about today. According to the International Energy Agency, global industrial emissions must decline by as much as 94% to reach mid-century climate goals. That's near elimination of emissions from this sector. So it's a huge task ahead of us that we have to focus on. As you heard from others and from Jesse's presentation at the beginning, in 2019, direct industrial greenhouse gas emissions in the US accounted for 23% of total US emissions. So that makes it third behind electricity and transportation. But when you also factor in the electricity use of the industrial sector, which is a key part of their emissions, it then becomes the largest source of emissions. So something that we just can't afford to ignore as we think about dealing with climate change. The other challenge, which you also, Jesse, touched on, is that the carbon emitting processes in the industrial sector are often much harder to address than other sectors of the economy. The technologies needed to reduce some of these emissions are either in the very early stages of research or not broadly deployed in the marketplace, even where they do exist and have been tested. And so if we're going to reach the ambitious goal of net zero by 2050, we really have to be working now to set the stage on how to address these hard to eliminate emissions, the emissions that we often call the last mile of decarbonization, because they're so important, but we don't yet have the solutions broadly deployed. So like some of the other speakers have mentioned, there are a lot of different approaches to dealing with emissions in the industrial sector. That includes things like dealing with, supporting nature's carbon sequestration processes, which can help us offset emissions while we wait for technology to develop, improving energy efficiency in industrial facilities, and electrification. But with all those solutions, we're still not going to be able to cover all of the emissions from the sector without technologies like carbon capture, which is why we view it so critical to getting to our climate goals. In its 2020 analysis of scenarios for limiting warming to 2 degrees Celsius, the International Energy Agency found that carbon capture could play a significant role in reducing emissions from industries where no other cost-effective way to decarbonize exists. IEA projected in that modeling that CCUS will achieve 15% of cumulative emission reductions needed to reach net zero by 2070, and even more if to reach a 2050 goal. Lee also mentioned the most recent IEA report on net zero by 2050, which continues to show a very significant role for carbon capture in meeting decarbonization goals. So in other words, carbon capture can play a critical role in getting to net zero by 2050 by helping the most carbon and heat intensive industries operate with little to no greenhouse gas emissions while retaining and creating high wage domestic jobs, which you're going to hear more about in the next from the next speaker. So one final point I want to make as we think about industrial decarbonization and the role of carbon capture, and we strive to reduce these emissions, which are absolutely critical to reaching climate goals, we have to really listen to local communities, ensure that their concerns are being heard as we move to this transition. And this definitely includes overburdened communities that have historically experienced the greatest impacts of air pollution and will be on the front lines of climate change. I think we can do all of those things, but we have to really focus on that piece as well. So in closing, carbon capture is a really promising solution that we need to get to our climate goals, but the technology still needs policy support to achieve broad commercial deployment. That's why we're very encouraged by the bipartisan support in Congress for policies to accelerate the deployment of carbon capture. The bipartisan infrastructure bill, which others have talked about, included an array of investments to really help make significant progress. But the policies under consideration in the Build Back Better legislation are really critical for speeding commercial deployment of carbon capture and other clean energy technologies. We really need that additional legislative support. So we're very hopeful that Congress will act soon on these additional policies to speed deployment of this very essential technology. So with those comments, I'll turn it back to Ben. Thank you.
Jason, thanks so much. And if you want to know more about Jason's comments on the last mile, he wrote a blog post on the TNC website last year, and it's so good that we keep highlighting it over and over and over again. So go to the TNC website and look for Jason Albritton, The Last Mile, and you can read more on that. And speaking of the first mile, our next speaker, Zoe Lipman, is actually fairly new to the AFL-CIO Industrial Union Council, the brand new deputy director. So congratulations on your new job, Zoe, and welcome. And over to you.
Thanks so much, Ben. As Ben said, I'm Zoe Lipman. I'm the Deputy Director of the Industrial Union Council of the AFL-CIO. though I have worked with many of these folks, and I recognize some of the folks on the phone here or on the Zoom here from a long history of work in around this sector, and also broadly what we need to do to lead in the clean manufacturing and clean industries of the future as a nation. And where the things we're talking about today are absolutely critical. As Jason mentioned, and as even the IPCC highlighted in their last report, carbon management and reducing carbon emissions from industrial facilities in particular will be central to meeting our climate goals. But it will also be central to ensuring that we strengthen and grow a domestic industrial sector that is the cleanest and the most competitive in the world, while securing and creating the next generation of high quality jobs. As we invest in building the next generation of infrastructure, as we've just seen with the bipartisan infrastructure law, and the next generation of energy and vehicles, it will be absolutely essential that we simultaneously invest in the processes and technologies needed to produce low carbon steel, cement, aluminum, glass, chemicals, and other critical materials that go into them here in the US. These industries are just as essential to the coming clean economy as they are to today's. They also support hundreds of thousands of high quality union jobs, hundreds of thousands of good jobs in industries that have, in many cases, been particularly hard hit by decades of bad industrial policy that saw domestic production offshored, often to places where both environmental and labor standards were lower, meaning that we were offshoring jobs and increasing emissions at the same time. US heavy industry has some of the cleanest and best labor standards in the world, but as it stands now, we're still seeing some of the most cutting edge technologies, particularly in industrial process innovation, being implemented overseas, in some cases with technology invented here, and as a direct result of policy support in those countries designed to speed implementation. That's why, as we look at the policies that are under debate now, we are, as others also said, very encouraged and gratified to see that not only is Congress proposing to make investments in modernizing heavy industry at globally competitive scale, but they are coupling those policies with labor and domestic content standards that are necessary to ensure we're sustaining and growing good jobs here and enhancing local benefits as we transform these critical industries. We've seen some really important first steps in the bipartisan infrastructure law that includes, in addition to the carbon management provisions that Lee and Jesse mentioned up front, $8 billion investment in hydrogen hubs and additional funding to spur manufacturing in the US of electrolyzers and other related technologies, as well as, and critically, as we make these investments and as we implement both the carbon management and the process and industrial changes in IIJA, it's critical to make sure that we have the high labor standards and the domestic manufacturing. We implement the labor standards and domestic manufacturing requirements as well, and that we're building networks of suppliers, which together not only ensure we're building good jobs in the implementation of these projects, but in the manufacturing supply chain, the pipelines, the electrolyzers, the long-term economic development and growth. Maybe I would also throw in the very important mention that Jason just made to ensuring that we're building pathways into good jobs in the clean and equitable industrial production in these local communities. The bipartisan infrastructure law provisions have been supported by the action that was mentioned earlier by the administration just last week, not only to begin implementing these investments, but to launch buy clean procurement and trade policy that would support clean manufacturing, and to responsibly advance CCUS implementation. But again, underscoring what Jason said, more needs to be done if we're going to act at the kind of scale we need to compete globally. This really is where the Build Back Better provisions are critical. Build Back Better is a major manufacturing and industrial bill. And I'm happy to talk in another event about the very critical investments in the bill around clean technology manufacturing and supply chains. But it also provides critical support for transforming essential, basic, and energy-intensive industries. And I want to just flag a couple provisions, note a couple provisions. As others have mentioned, this does include the expanded increased 45Q for industrial decarbonization, but also tax credits that directly support hydrogen production and deploying a wide range of industrial technology and process changes that cut emissions. It also includes direct manufacturing and industrial investments, financial support that can be used to deeply cut emissions from industrial facilities, both through carbon capture and as well as fuel and process change. And not only deploying first-in-class technologies, the kind of thing we are competitively seeing overseas, as was mentioned earlier, and want to compete with here at new and existing facilities, but also to ensure retooling at major economically critical facilities that make materials that our economy depends on. Finally, amendments, I would flag that there were amendments to the House Competes Act, the House side version of the USICA bill that was passed recently that would make similar large investments in deploying deeply carbon reducing technology at major industrial facilities. We need to get these over the finish line to move towards a clean and competitive industrial sector. And done right, these policies will provide the domestic and global markets we need to ramp up the production of clean materials, the investments in today's plants and in new ones to ensure that we are meeting that demand domestically, the domestic manufacturing standards and incentives necessary to ensure we're building jobs not only in carbon management and retooling projects, but throughout the supply chain for the same materials and technology, and the labor standards to ensure we're maintaining and growing good family supporting jobs and broader and more equitable pathways into those jobs in the clean economy and for the decades to come. So thanks very much and look forward to answering any questions. Thanks, Ben.
Zoe, thanks so much. And wow, I can see why you were hired. That was great. So there's a bunch of questions in the chat. I'm going to do my best to read them in the order we got them. So the first one is from David Mitchell at the Advocate in Louisiana, and it's directed to Colin. Colin, can you talk more about ADM's goals about replacing petroleum-based products with plant-based products? Was the just a general reflection of your efforts to decarbonize, or are there specific products that use petroleum in some way that will now rely on grown crops? If the latter, can you provide some examples?
Sure, it's a great question, and when you think about what ADM's doing and how we're shifting our business around, we have a new sub-business unit called Bio Solutions that's looking at replacing petroleum and other non-grown crop type feedstocks into more of the corn-based products or those types of things. So we're shifting and looking at existing products into new markets. But to get to your point about the petroleum-based products, ADM announced a project, and this is just one project, but we announced a project with LG Chem late last year where we're going to construct a lactic acid facility and make polylactic acid, which is a replacement for petroleum-based plastics. We're also looking and working with LG Chem on a joint development agreement to develop a bio-based acrylic acid. So, I mean, those are just a couple examples of replacing petroleum-based products with, I'll say, corn-based products in this case.
Thank you very much, Colin. A question from Amina Saeed, IHS Markit's Net Zero Daily. She asked about how many operating carbon capture facilities exist in the US and globally within the industrial sector. And Lee put in the chat a link to the Global CCS Institute database, so you can look that up. So hopefully, Amina, that is helpful. Lee, did you want to add anything? Because I think you talked about numbers.
Yeah, I can just that oops, I'm unmuted, sorry. That in the US, there's 12 operating facilities that are currently capturing and storing CO2. So I think, and it's roughly, I think, somewhere around 20 to 23 million tons of CO2 that's being captured and stored.
Thank you. And here's a good question, especially for beginners looking at this, also from David Mitchell at The Advocate. Can someone here talk about the geology of storage as far as its long-term capacity to hold ever-growing amounts of CO2? Is there a limit? Nothing in nature is infinite. What is the ultimate amount of storage these formations can hold? How many years of industrial activity does that capacity get us? And is there a plan for the day after that limit is met? I have a feeling Jesse might want to answer this, but anyone
Sure, happy
can.
to take it, Ben. Thanks, David, for that question, and I'll put this resources in the chat. Actually, I just pulled it up. The Department of Energy has a carbon utilization and storage atlas. And so this is one case where the United States actually has an overabundance. Geologically speaking, we have abundant suitable storage. So we have about 2,400 billion metric tons of appropriate CO2 storage. Now that is hundreds of years of industrial emissions, and we're not suggesting that that's just what we should do, but that storage capacity is not a concern when it comes to capture and storage. Certainly there needs to be additional site characterization as far as when you go to do individual projects, but the capacity is certainly there. And so I'll put that resource in the chat.
Jesse, thanks for putting that geology degree to use. Good use there. Next question is from John Funk at RTO Insider. No one today has revealed just how processed carbon dioxide is captured. Is it done through filtration, membrane sorting, or chemical reactions? I'm guessing many of you might want to answer that, but who wants to go first? Jesse,
I'll take a stab at it.
Great.
It's a good question. It really, I think it was someone in the chat, maybe it was Mark or someone, put in a really good story that gave an overview of all the different technologies.
Craig Bettenhausen.
Oh yes, I think it was a great story. It's something that I use personally in my own research. So thanks for the cliff notes, but it depends on the technology provider you're partnering with. So in Colorado, for example, we are partnering with Savante, and Savante uses scrubber technology. So the best way I can think about it is putting a vacuum on top of our smokestack. That vacuum is powered. It spins at high velocity with a nano filtration particle system that kind of scrubs. In one end comes nitrogen, in the other end comes the carbon, and then we kind of compress that, liquefy it, put it into a pipeline, and either send it to storage or EOR, and that's what we're trying to figure out. In our Missouri project, we're partnering with Air Liquide, and they are using a different kind of technology that is cryogenic, I think is the best way to describe it.
Thank you, Leo. Anyone else want to add a little bit more color to that before we move on?
I'll just jump in real quick, Ben, and say that Lee and I both shared the same fact sheet from the Global CCS Institute that just kind of provides a nice overview of the different capture methods, pre-combustion, post-combustion, as well as oxy-fuel combustion capture. So just kind of the different technology pathways on the capture side.
Thank you. And Kay Kaufman from RTO Insider asked another question, which I think we've sort of answered with thanks to Craig's useful article. What is the metric cost per ton for gauging the competitiveness of CCS? What is it now, and where does it have to go with and or without 45Q? I thought Jesse or someone else might want to at least touch on that quickly.
Yeah, I'm happy to jump in here, Ben. I just posted again the Rhodium Group industrial decarbonization 45Q analysis, because it actually gives you the current costs of different applications and how they compare with an $85 45Q. I will say that again, each application is different, and just a per ton cost I think doesn't really do it justice, because of course there's additional aspects we have to consider, for example, CO2 transport and CO2 storage, but also the value that carbon capture can deliver in these industries beyond, for example, by creating and maintaining jobs, making sure we can decarbonize industries that we couldn't otherwise decarbonize. And of course, there are multiplier effects of CO2 transport and storage infrastructure. I think in general, assuming a 15% learning rate, so every time we build a second of a kind facility, costs would come down 15%. That's, for example, the learning rate of wind. Costs are expected to come down relatively quickly. And the goal is really to unlock cost reductions by learning by doing. And historically, innovation analysis has shown that most of the cost reductions, say if we're thinking about PV solar, were achieved by technology-specific deployment mechanisms such as the German feed-in tariff, while only very little was contributed by, for example, research. So getting the steel in the ground, making sure we're deploying these technologies today will help us lower costs, learn more about the technology, de-risk it with regards to investors, and will also unlock it to be deployed globally. So I'll stop here. I hope this was a helpful answer, Kay.
Thanks, Lee. And a question for Leo from Mark Schliefstein from the Times-Picayune, also in Louisiana. Leo, there are lots of individual Lafarge facilities around the country. What will local carbon capture look like for these small facilities? Great question.
Yeah, that is a great question. So what most people see from Lafarge Holcim is actually our concrete operations. So we have 13 cement plants. We have a terminal network where we distribute cement, and that cement is sold to markets. But 70% of the cement that's manufactured goes to ready mixes, which is going to see the spinning trucks you'll see in your communities. And I'm very excited to say that on that front, we are actually doing a lot, and we have a lot more levers to reduce the carbon footprint of concrete, and that could be utilizing recycled concrete, utilizing low carbon cement, changing kind of the concrete recipe, whereby we actually just launched last year something called EcoPack, which is our blend of low carbon concrete. So that's what you're going to see in a lot of your communities, and we're rolling it out across the United States. But the big carbon emissions are actually from the cement plants and cement manufacturing sites.
Another question for Mark, this time for Colin. Colin, are any of ADM's carbon reduction efforts aimed at development of natural sequestration measures that might also capture nutrient runoff from companies' farms?
That's a really good question, and it's something that ADM has been active with. We've been working with farmers on implementing really climate smart agriculture. So reducing the amount that's applied to a field to reduce the potential amount that would result in runoff. So if you can spot or be smart about where those nutrients are actually applied, you don't over apply, and there's less of an issue with runoff. So that's how we're approaching it today in terms of trying to minimize what is put on the field.
Thank you. A question from Craig Bettenhausen at Chemical and Engineering News. Strategy Q for the policy folks, he says. Which is looking like a better bet for getting 45Q enhancements enacted? Reviving Build Back Better or moving it to a standalone bill? Anyone want to give that a try?
I'd actually like to pull in, I'd like to call phone a friend. We have Madeline Morrison, our external affairs manager for the Carbon Capture Coalition on the line. So Madeline might have some thoughts on this question.
Madeline.
Yeah, hi everyone. Thanks for the question. I don't think we're willing to take bets on that yet. I think things are still very much up in the air as the Senate is really focusing on, a handful of other important issues right now. But I think what is clear is that any further iteration of Build Back Better is going to likely be much smaller than what is currently in base text. So I think the one really good thing that we've been hearing, especially from carbon capture champions on the Senate side and even Mr. Manchin himself, is that the climate and energy tax package is the most well negotiated portion of Build Back Better. So I think that really bodes well for any further iteration of this budget reconciliation text.
Thank you, Madeline. Oh, go ahead, Zoe.
Could I maybe jump in there too? And I'm very glad that somebody else took the basic question, but I would just to underscore what Madeline just said, the climate and energy portion, I mentioned that this is a manufacturing and industrial bill, also includes very, very significant both grant and loan, but also tax credit incentives for manufacturing of the next generation of energy and climate technology. And that includes investments in deploying carbon reducing technologies in heavy industry. All told, maybe something that would incentivize something in the realm of $100 billion in new manufacturing investment across both clean energy technology supply chains, but also, as I said, very importantly, in all of these sectors that we've just been talking about. And so I just would underscore that that's a package that provides the kind of demand side and supply side and comprehensive manufacturing and industrial policy that we've needed for decades to really ensure we can rebuild manufacturing and supply chains from steel and cement all the way through the advanced clean technologies of the future and compete with the rest of the world that's taking similarly aggressive action.
Zoe, while you're talking, we'll do our last question. Rick Weber from Inside EPA asked if you would expand on what you said about amendments to the House passed bill.
Sure, and I dropped it into the chat too, and I will have to say that question got me quickly trying to pull up the amendment list to remember which ones they were, the actual names, but it was the Castor and Doyle amendments. They do two things, but they together invest in, provide $14.5 billion in investments in both first-in-class industrial retooling, industrial technology deployment, and broad-based both efficiency and other emissions reducing technology and including carbon management deployment in industry.
Thank you so much for that. We have a lot more questions. We will capture all of those and follow up with you individually so that we don't miss the chance to make sure we address them. But we did ask for an hour of your time and we want to be true to that. So thank you all for joining us today. This has been an amazing conversation, at least from my perspective. I hope it was for you as well. We appreciate the insight from our special guests and the great questions from all of the participating reporters, and we hope this conversation was helpful. If you'd like to know more or you want to follow up on anything from today's conversation, including the slides, which I will share, or if you have an interview request for me, please get in touch with me, ben@renewpr.com. I'm sure you all know that from all of my emails, but just in case you missed it, please join me in thanking our guest speakers, Lee Beck, Leo Barrera, Colin Graves, Jason Albritton, Zoe Lipman, and thanks as always to Jesse Stolark and Madeline Morrison from the Coalition staff. Please follow the Coalition on Twitter at CCS Tech Facts. And thanks again for joining us today. Please be well, be safe, and take care.
Thank you, Ben.